In this video we're going to look at polynomial and rational inequalities. So we are going to have three ways that we can solve polynomial or rational inequalities. Dependent on whether or not it's polynomial or rational, I would pick a different method. Graphing to me is by far, and this first one we'll look at, is the easiest one for the polynomials because they're really easy to graph. Graphing rational functions can be kind of dicey, so it would probably be my last choice in terms of graphing rationals. We're also going to use test points, which is the one that students tend to like, versus sign charts, which is the one that maybe math teachers tend to like. Test points is a little cumbersome in that you just have to do a bunch of calculations. It's not hard, it's just kind of annoying. Sign charts are harder to understand at first, but then once you get it, they're really, really easy. So I'll show all three of those, and you can kind of pick and choose which method works best for you. For solving an inequality by graphing, the first thing we're going to want to do is graph the function. And so this is going back to our polynomial graphing. And then if we are looking for greater than or equal to 0, we're looking for what values of x do we plug in that make the output, the y value, be greater than 0. So essentially what we're going to look for is all the places where the graph is above the x-axis. That's where the y values are 0, and that's going to be our solution set, the x's that make that happen. If it was a less than, we would be looking for the parts of the graph that were under the x-axis, and then the x's that made that happen would be our solution set. So let's see what this looks like. My pen back. So to graph this, let's see, we got x equals 0, -3, and 3. And these are all to the first power, so they are all crossing, and it's 1, 2, 3 x's, so it's an x cubed. So remember, that one comes in from the bottom and leaves out the top. So let's get our intercepts sketched in there. And then I'm going to try to draw a somewhat smooth curve. Again, it doesn't matter how high or how low you draw this. You're mostly trying to draw this for clarity for yourself so that you can see what it does. It would take some calculus in order to find the high and low points on that, so we don't have to worry about that. So coming in from the bottom, we're crossing at 3. We are attempting to cross at 0 and then crossing at 3 again. So something kind of like that. We want this to be greater than 0, so greater than 0 is going to be all these parts that are above the x-axis. So any numbers in between -3 and 0, when I plug them in, so for instance if I plug in x equals -1, that's going to come out greater than 0, as are all the numbers on that interval. Likewise, everything out here is going to be above the x-axis. And so any numbers that I plug in after 3 are also going to keep that greater than or equal to 0. So my solution set is, it's the x values that make it happen. This is an equal, so I would want to include the endpoints. So it's going to go from here to here, that stuff in between, and then from here out to infinity. So that would be -3 to 0, union 3 to infinity. And that's it for graphing. So if you're fairly reasonably good at graphing polynomials, it's a really quick little, draw a couple of curves and go from there to there, from there to there. So solving using test points. This is my least favorite method. I find it super annoying, but you may like it. I don't, but that's okay. I often find that students do like this one. So what we need to do here is find the same thing. We find our zeros, and we have an equal, so I'm going to throw down solid dots on these zeros. And then notice that kind of breaks the graph up into 4 distinct regions. There's out here in between -3 and 0, between 0 and 3, and then from 3 to infinity. So what I did was I picked a number from each one of these intervals, -4, -1, 1, and 4. Basically, I picked the easiest numbers of them. Anything on the interval works though. And then we're going to plug it in here and see what happens. And if it comes out positive, that's greater than 0. And then that means that interval works. And if it comes out negative, that wouldn't be greater than 0, which means that interval doesn't work. So it's basically just a bunch of plugging in numbers and evaluating. And maybe I will show, this is going to bounce back and forth like it just did. So maybe I will just show the work on one of these and then go, here's what you would get if you did the rest. I'll shorten up the video. So that'd be -4, -1, and then -7. So if I multiply all those together, I get -28. And then we would do the same thing with -1, 1, and 4. I'm just going to write down the answers here to save a little time. If we plug in -1, you're going to end up getting 8. If you plug in 1, you will get -8. And if you plug in 4, you will get +28. And so what we can take away from that is, let me write those numbers down. So this one came out -28. This one, -1 came out 8. 1 came out -8. And this one came out 28. And then we'll switch over to red. So -28 is not greater than 0, so that part didn't work. 8 is greater than 0, so that means everything in between here does work. -8, not greater than 0. 28 is greater than 0. So we use test points to establish which intervals satisfy that inequality. Here I took it all the way to numbers. You don't have to. You really only care about the sign. So if you wanted to speed this up a little bit, you could go, so if I put in -4, that would be negative, that would be negative, and that would be negative, which means I'd have a negative number, which means that didn't work. So you can do it with just the signs and figure out the sign. You don't really need the number, just the sign of the number. So that is test points. I'd much rather graph it. That seems far less cumbersome to me. That said, for the rationals, some people might prefer this one to the next one. This next one is called a sign chart. And this is the one, like I said, that is a little bit hard to understand initially, and then once you get it, it's really easy. And I prefer this for the rational one because I don't like to plug in a bunch of numbers. So same first step. We have this, we're going to find our zeros at -3 is one of our zeros, 0 is one of our zeros, and 3 is one of our zeros. So I'll just kind of set that up on my number line. And these are just showing I have a factor of x, and it's 0. That's what that's supposed to be. Doesn't really look like a 0 for some reason. But its 0 is right there. -3 goes with x plus 3, and 3 goes with x minus 3. And then what we do is we test the signs in each of these factors. So if I put -4 in for x, it's negative. If I put -1 into x, that's a negative. If I put 1 into x, that's a positive. And if I put 4 into x, that is also a positive. And then I'm just going to keep doing this with all three factors. So if I tested -4 in that, it's negative. If I tested -1 in there, it's negative. -1 minus 3 would be -4. If I tested 1 minus 3, that would still be negative. If I put a 4 in there, it's positive. So you might start seeing a pattern here. To the left of the 0 is going to be negative. To the right of the 0 is going to be positive every single time. If you think about the graph of y equals x, it is negative to the left of the 0 and it's positive to the right of the 0. And that's exactly what we're seeing here. So it's going to be negative on this side of its intercept and positive on that side. So once you accept that, you can fill these in really fast. -4, right, that's going to be negative, and then after the 0, it's going to be positive the whole rest of the way. because -2, it would be 1, that's positive, and then it stays positive. So these are, unless there's a square or a negative x, it's going to go negatives and then through 0 and then positives every single time. So what do we do with that now? Well, now we can just multiply up the negatives and positives. So 3 negatives would make this region negative, 2 negatives makes that region positive, 1 negative makes this negative, and then that's all positives. And we want greater than or equal to x, so that means we want the positive regions. And so once again, there's that same interval from -3 to 0 and from 3 to infinity. So same problem, 3 ways. If you were only going to learn one, I guess it would be test points. Graphing is really terrible for rationals. Like I said, I like it for polynomials, and that's how I'll show the rest of the polynomial examples. I prefer sign charts, so I'm going to show the rationals as sign charts. That said, you can use test points if that's your preferred method. Okay, so let's look at some different examples that aren't the same one over and over and over. Solve this inequality. Okay, so the first thing I need to do is get that factored so that I can see what's going on. -12 adds to 1, so it sounds like a +4 and a -3. And I want less than or equal to 0, so I'm going to want the region underneath the x-axis. I have intercepts at -4 and 3. And this is a parabola, so, and I don't need to worry about the vertex or graphing it precisely. I just want the parts that should be on over the x-axis where they should be and the parts under where they should be. So there's -4, there's 3. You attempt to draw something kind of parabola-like with this pen. And we want the less than or equal to zeros. So that means I want those intercepts. I want to include those. And I want to include that whole region because all of this is under the axis. So like if I put in 0 into this, -12 is less than 0, that makes it true. So we want that whole region. So solution set's going to be from -4 up to 3. This next one we have, let's see, x equals 0 and it's cubed, so that is going to cross. We have x equals 6 and it's squared, so that one's going to bounce. And x equals -5, and that's to the first, so that's going to cross. Remember, the other thing we need to do on this is figuring out what the end behavior is going to be, so we're going to go and figure out what our leading coefficient is. So x cubed, that would be x squared, so that's 5x's, 6x's. So if we multiplied all that out, we would get x to the 6th, which is positive even. So it looks like x squared, and it's going to open up. So we got a 0 at 0, we got a 0 at 6, and we have a 0 at -5. And then, let's see, we're going to come in from the top, and we're supposed to, at -5, we are crossing. We're going to come back and cross on that 0, and then we're going to bounce off of the 6. And again, don't worry about how high or low you're making the bumps. This is just so you can see where it's above and where it's below. So we want greater than 0, so that would be this region right here. The graph is above. And it equal to 0, so that means I don't have to treat the 6 specially in any way. All of this is greater than or equal to 0 all the way through there. If it didn't have the equals, I would have to have a little hole right here in the number line, and I would go up to the 6 but not include it and then pick up at the 6 again. I think I have one coming up that does that. But so this one's a little easier. It's just going to be everything from 0 on. So solution set should be from -infinity up to -5. And then union, because we got that gap in there. Oops, that should be a bracket. union 0 to infinity. So for this one we have x equals 6, and that's going to cross. X equals -2, and that's going to cross. And x equals 4, and that one is going to bounce. And this is going to be 1, 2, 3, 4 x's, so x to the 4th, so it's another positive even. We'll get these marked. And this one should start at the top. We're going to cross on the 2, and then bounce off of the 4, come back down. It didn't work as well as I hoped. Let's see. Come back down, and then cross again on the 6. And for this one, we want the less than, but not equal to 0. So this is where we're going to have a hole right here, because this spot is equal to 0, so I don't want to include it. And actually, all of these endpoints are going to be, would be holes if I was graphing it. I mean, parentheses when I go to write the interval notation. But all of this is under, and all of that is under. I just have to be careful not to include any of the places where it's actually 0. So that should look like from -2, which is under that big blob now, up to, that's 4, union 4 to 6. So notice how I'm excluding that 4 because, oops, I just got rid of the middle part of my graph, but because it comes up and touches at 4, I can't include it because of the equals 0. Okay, so then we got a few more examples here with solving rational inequalities. These are a little bit harder. We can use test points or sign chart. Graphing them is, like I said, fairly cumbersome on paper or pencil, especially if they get any more complicated than this one. And so I would either use test points or sign chart, as you prefer. The one thing that we do have to be a little bit careful, if it's a less than or greater than without the equals, it's great. All the endpoints are parentheses, you don't even have to think about it. But if it has an equals on it, we need to include the numerator we need to include the 0 from the numerator, because that one's an x-intercept, so that's where it would be crossing x, remember? But the zeros from the denominator, like in this case x equals 5, that one is a vertical asymptote, which cannot be included because it would be division by 0. So if we have an equals, like we do on this one, we're going to include the numerator zeros, but we have to exclude the denominator zeros. So right away, I could mark this graph with an open dot there and a solid dot. Did I do that right? Yes, a solid dot. No, I did it backwards, my bad. Open dot on the 5, solid dot on the 3, because we're going to include our numerator and exclude our denominator. So then we would have to do some test points. Again, I think I may just write down what I got. So I tested -4, I tested 0, and I tested 6. And so plugging -4 in there, I got 1/9. Plugging in 0, I got -3/5. And plugging in 6, I got 9. And so that means that -4 came out positive, 0 came out negative, and 6 came out positive. And I want the greater than or equal to regions. So that means I want the positive ones. So I want to include this endpoint because it makes the 0 in the numerator, which is its intercept. But I have to exclude the 5 because that's the 0 in the denominator, which is a vertical asymptote. So this is going to be -x to -3 bracket, and then union, be careful with that parenthesis right there, to infinity. And then same question, but with a sign chart. Let me write that down just above this so I can see it when I'm working on it. So what we did here was we set up our two factors, and then this top one is a 0. Because like I said, that's our x-intercept. The bottom one I put a u there. Sometimes I write undefined or UND as well. Just to remind myself not to include that point in the answer. So then we can try some test points just in the factors, or like I said, once we believe in it's going to be negative to the left and positive to the right, we can actually do this just that easy. But if you want to try some points, put in -4, it's negative. If you put in -2, it's positive, and once it's positive, it will stay that way. Same thing down here, -4, negative, 0, negative. If I put in 6, it's positive. And that would be our signs. And then remember, we multiply them together, or in this case, I guess we're actually dividing. But a negative over a negative would make a positive on that region. Positive over negative would make a negative. And two positives would make a positive. And so then we get the same solution set that we saw before. There to there, undefined at that point, going out this way. So the same old negative infinity to -3 with a bracket on that one, and then parentheses so we don't include the 5 up to infinity. Okay, so for these last couple, like I said, I'm going to use a sign chart, and then this way I will also set a couple up. These ones I had set up already, but I have a couple of examples where you have to kind of do it from scratch. So let me show you what that will look like. I'm going to get that denominator factored so I can see my factors. So I've got x plus 8 and x minus 8 less than 0. So this one's nice because it doesn't have an equals, so everything just gets a parenthesis and we don't have to think very hard. But when there's an equals, we do have to pay a bit more attention. So here we're going to do x minus 2, x plus 8, and x minus 8. And then I'm going to set up a number line. And you don't need your number line to be accurate in terms of how far apart things are. Better to just do 3 hash marks so you have nice clear regions that you can see rather than like numbering all these. That's actually, you end up with things really close together or really far apart, and people make a lot of errors that way. So I would just do this. Our zeros are going to be -8. Careful to get them in the right order though. This one would be 2. And this one would be 8. And then I will remind myself, actually there's no equals, so I'll just put zeros here, and then I'm not going to include any of those in my solution. So -8 goes with that one, 2 goes with this one, and 8 goes with that one. And then I like to draw a little vertical line right there, just to kind of help myself keep the regions separate. When I'm doing this on line paper, then I also have lines right there that again kind of help me see each of the regions. So hopefully we're getting where you're starting to believe if I put -10 in, it's negative. If I put 1 in, it's still negative. If I put 3 in, it's positive. And then if I put 9 in, it's still positive. So again, with the negative to 0 to positive. So once we accept that, then filling in sign charts is really easy. It is just that simple. Setting them up takes a second, but the filling them in, you don't really have to test the points because you know what it's going to do. Again, if there's a squared, which there will be on the next one, or if they happen to be a -x, then you have to pay a little more attention to the signs. But otherwise, that was it. 3 negatives would make negative, 2 negatives would make positive, 1 negative makes negative, and then 3 positives would make a positive. And we want what? We want negatives, so that's over here. Not going to include the endpoint. We don't want the positive part. We want this other negative part here. And that will be our solution set. So this is going to go from negative infinity to negative 8, union, 2 to not infinity, but 8. Okay, so for this last one, we will start with some factoring. We're going to have x multiplies to 12, adds to be negative 7, so negative 3 and negative 4. For the denominator, it has to multiply to be 25, add to be 10, so that'll be x plus 5, x plus 5. But let's write that as x plus 5 quantity squared, and then greater than or equal to 0. And then this one has an equal, so I will have to pay attention to not include the negative 5, but I do want to include the 3 and the 4 that are coming up. So we'll set up our sign chart, x minus 3, x minus 4, and x plus 5. So I have solutions or zeros at negative 5, at 3 and 4. So negative 5, I'm going to put a u on that one. Actually, let me get my green lines drawn in here. So I'm going to put a u there to try to help remind myself to not include that in my solution. 3, that one's 0 is right there, and for 4, that one's 0 is right there. So these first two factors, they don't have the negative on the x, which would reverse all the signs, and they're not squared, and I just realized I left the squared off that x plus 5 down there. So we'll get that back. So it's just going to go negative, negative, positive, positive, then negative, 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 and positive. For x plus 5 quantity squared, because it's squared, it's going to be positive everywhere. If I plug in negative 6 plus 5 would be negative 1 squared, and it'd still be positive. If you think of the graph of this, it's never negative, right? It's our parabola, and it's shifted 5 units to the right, so it's 0 or positive everywhere. So we just fill in all positives. And then kind of tallying this up, 2 negatives make a positive, 2 negatives make a positive again, 1 negative makes negative, and 3 positives make a positive. We're going to have the positive region, so I want this, but I don't want that point because it's undefined, so I'm going to throw a open dot there to remind myself. And then we want the positive region. I want to include the 3 because it's from the numerator. Likewise, I want to skip over the negative region and then include that 4. So my interval notation for this one is going to go negative infinity up to negative 5. And then I'll pick back up with negative 5 again. I'm just excluding negative 5 itself. That's going to go up to 3. Oops, and that one should be a bracket. And then this one should also be a bracket for to infinity. So they're a little involved. Like I said, the sign charts, there's no actual math in them once you get how to use them. If you're not comfortable with these, you can absolutely do the same exact thing with doing test points. You would set up that same number line, you'd plug negative 6 in here and see what happens. It'd be positive. Between negative 5 and 3, I would pick 0 because it's the easiest number. See what happens. 3 and 4, you're probably going to pick 3.5 and throw that in, and then maybe 5 and throw that in. And remember, you don't need to know the actual number it comes out to, just if it's going to be positive or negative. So once you can see that, then you can fill in these ones I have in the parentheses down here and get to the exact same place I did.